Hello everyone, welcome back to Rust Programming Tutorials. Today we are going to talk about packages and crates. In the last session we talked about options, enums, struts. We have covered packages. Okay, so today we are going to talk about packages and crates. As in any programming language, we don't have just one program. Rust is a programming language. It's not just a script like a bash script or a Perl script. It's a full-fledged programming language. So any programming language, they share code. They have libraries. We have packages, right? So you can organize codes, related codes into some modules, packages. So same features are available in Rust also. So today we are going to talk a little bit more about packages, crates, how to access the modules, functions. We are also going to talk about the public keyword to define the scope of any function or a module inside a library file so that it can be accessed outside. So what is a crate? Until now, all the examples that we have seen, okay, they are nothing but crate. They are the smallest amount of code that the Rust compiler considered. Now, crate can contain modules, and the modules may be defined in other files, like how you can import the module, but then they get compiled with the crate. A crate, you can have two forms, a binary or a library. Binary crates creates an executable, like what we were doing when we do cargo run. It creates an executable file for you, which you can run the program. Like it should have the main function in it. Then there is another version of a crate, which is a library, which contains reusable codes. Like say, for example, string functionalities or any other functionalities, like some mathematical functionalities, they are all available as a part of libraries. For example, if you're familiar with the Java, you have different packages, java.util, java.concurrent, so many different packages, right? Same way you have packages which you can import here, okay? Same way you can create libraries and import libraries into any crate. The difference between a library crate and a binary crate is that they do not have the main function and they do not compile to be executable. And of course, because it's a library, you will share it across multiple projects. They're reusable codes. Now, package is a bundle of one or more crate that provides a set of functionality. Say, for example, collections package. It will have all collection functionalities available. Okay. A package contains cargo.toml file that describes how to build those crates, like what is the version available, those kind of information is available. One package can contain many binary crates, okay, but only one library crate. Now, this is important to note. If you create a package, you can have many binaries, many crates, small crates, but only one library crate. And one package must contain at least one crate. And otherwise, what it is? A crate is nothing but similar to a program that you write, right? If in a library or a package, you don't even have one program, what is it about? What else will it contain? Just comments, which is not of any use. Now, how do you declaring modules? Now, what are modules? So packages, crates, and modules. In the crate, you can create new modules. Okay. Say, for example, you're creating a garden module. You will create it with this. This mod is the keyword. Okay. Followed by the module name. So when you declare this, the compiler, when you compile it, it will look at inline, like within that crate itself, or under the source directory, it will look for this file garden.rs, or under this way, source garden mod.rs. This is the hierarchy in which the compiler will try to find what does this module contains whenever you're using the module inside a crate. So when that crate is compiled, this is the way it will use it. One module can have another module also. It can have a sub-modules, okay? In any other file, other than the crate root, you can declare the sub-modules also. So like say, for example, in garden, you can have vegetables, okay? And then that will be in this file, garden.rs. Now, again, the path will be same. Where will the compiler look for the submodule? In this inline, whether it's present in the current module, or here, if it's under garden, vegetable. See, it's not in vegetables, right? Because it's a submodule. Garden.vegetables.rs or gardens.vegetables.mod.rs. So if the Rust program is not within the parent, it could also be in its own directory. So see, the directory has to be the same name as the file. If it is present in the parent, see here, garden is the parent. So the name of the file is vegetables.rs. But if the code of the module is in mod.rs, it can be in its own directory. Okay, so that is what the path is. So the absolute path is here. So say, for example, each each section of the path is separated by 2 semicolons. So the topmost is crate, followed by the top level module, followed by the submodule. Okay. Now, again, if there is another module called asparagus in vegetables, it will be accessed this way. Now, private versus public. A code within a module is private by default. All the codes are private, which is accessible within that code itself, within that function itself. If you want it to be accessible outside the modules, the functions, you have to use pub, public keyword. So it's not public, it's pub. So when you say pub mod, instead of just mod, it becomes public. And now any other crate would be able to use this. To make items public, we can use pub before their declarations. Okay. Now, see here, the use keyword is used to import the modules, like similar to import statements in Java. I think use is used in Python also. I'm not 100% sure, but I think use followed by the library name is or it's from something. Yeah, forget. In some language, I remembered its use is there, but you give the absolute path. So say for here, sorry. Where am I? Here, yeah. So in a code, you will give the absolute path where it is, and then you use public mod garden, and then here you are defining whatever the functionality is. It's a crate, it's an executable crate because it has the main function. So when you group code inside the modules, so let's say, for example, here it's a module front of the house. Now here again one module containing another module hosting, and then this has functions, different functions. This module can have multiple functions, and again this module front of the house also have another submodule. So this one has 2 submodules, hosting and serving, and each one can have its own multiple functions. Okay. And again, see, there is no public key, pub keyword outside before it. So it's not accessible outside. Okay. I also wanted to introduce the super keyword. Now, super means the parent. Okay. So we can, and it allows relative paths rather than you giving it the full absolute path. You can use super keyword to reference an item that we know is it in the parent module. Okay. So this will look it in the parent module. Okay, so that is there. So here, see the fixed incorrect order function is in the back of the house. So we can use super keyword to go to the parent module of back of the house, which in this case, it is just the crate. Okay. So we can use public keyword to designate struct. So not only pub keyword can be used for modules or functions, it can also be used for struts, enums to make them public and accessible outside. One thing to note, even if you make a strut public, the fields, the properties that are there inside the strut, they are still private, which is accessible only within the strut. So say, for example, if you had a Java class, all the field members are private. Only the class is public. Okay. And you can, of course, choose to add public keyword or to make it public on a case-by-case basis if you need it. So this was all for today. So we learned about what are crates, packages, modules, public keyword, super keyword, how do you use keyword, how you define nested modules, okay, how do you access modules or call functions of a parent module, and how do you use the absolute path. Okay, so this is all for today. Let's see one in practical example. Let's see a practical example. Yeah, here. So see here, I have declared a public module. So say it's public module bar. It's a function you're calling foo a. So foo is a parent, and within it there is a function called as a. Now see here, it's public. So this should work, and it should print what? It's calling another another function from module bar.b. So it should print b. Let's see it in action. Let's run it. Let's run this code, and here you go. So in order to run this, you give the command cargo run, and see here the directory. I'm in this, where this is, and I go cargo run, and it prints b. So it's like, now here, see here, if this was not public, okay, let's see what happens now. If this was not public, so see, even though public function is, they are all in the same module, let's see if we can access it. Yes, you can. So now within the function, you can access it. I mean, within the same module here, even though bar is not public, still it's able to call it. So package modules are accessible within the package without defining the public keyword. Now let's see if I can call bar here. Okay, directly if I can call bar. See, the function A was public. Oh, bar is not a function, sorry. Bar colon B. Okay, so bar is a module. If I want to call it B, this one. Okay, now let's see what happens. Now it is complaining, right? B is not publicly re-exported. Okay, so now even though the function is public, the module is not public. But now if I make the module public, then let's see what happens. Now it's accessible. Okay. So that is all for today. We have seen how to declare modules, run it. So this is a binary crate because I could execute it. Okay, it's not a library crate. Library crate is lib.rs and it does not contain, you cannot run it. You can only use it or import it. That is all for today. See you all again in the next session with some more Rust programming. All right. Thank you for your time. See you all next time. Bye.